All right, so the very first thing you want to know is your area formulas. You got a handout at the beginning of this chapter that dealt with area formulas. So you should have a handout that has all of the different area formulas on it. So when you see something like a triangle, do not let it throw you that it has this little piece right here that is just the height. So you need to know your rectangles. You need to know your triangles. You need to know your trapezoids. Right? We added to it circles, right, which are coming later, but and then of course your regular polygons. All right? You have a separate handout for rhombus and kite. It actually has the formula on there. All right? So lots of formulas on this test. So what I would do is I would go through these worksheets and kind of write the formulas as you go. So when you see a picture of a trapezoid, you're like, oh, I know what that formula is. All right? So that you are looking at it. Your handout that I gave you has the first ones on there. It doesn't have the circles or the regular polygons, but it has the other ones with a picture of it and what the formula is. All right? So you want to make sure you're studying that. So that's really that first and second page is just checking your formulas for those polygons, all right? Plug it in and solve. Notice that here we have units, right? So watch your units, and it should have done it on your review, but watch your units and make sure that you have the same units. And then there are going to be times when I hand you the area and I want you to give me one of the dimensions that I'm missing, all right? So when you get here, your answer should be in the units that it's given. Squared, here's your kilometers right here. So you know your answer is going to be something in kilometers. For these, you're actually taking the formula that you know. So for this one, base times height is my formula for the rectangle. They gave me one of those. So I'm just back solving into it. My area equals my base times my height, which I don't know. Divide and solve. All right? So when you're given something like this and they give you the area, you are just backing into it. You're backing into that area so that you know what it is. So like 16, they gave me the area of 16.5 square feet. That's what they gave me, by the way. It just cut off when I printed. All right, so I'm going to plug that in. The area of a trapezoid equals 1/2 my height. Base 1 plus base 2. And I'm going to solve. All right, you can go ahead and multiply the 3.3 times 0.5, or you can multiply both sides by 2, divide by 3.3. I know one of my bases. One of my bases is going to be 6.7. So I know one of them. I've got to solve for the other. All right? So you're just solving here. Divide by your 3.3 and then subtract your 6.7. So you're just back solving into it with algebra. All right? So you're in on that second set of area problems, you're using the same exact formulas. You're just going to be missing one of the variables within the formula itself. So when you're missing one of the formulas within the variable itself, then you want to back solve into it. Back solve into it. All right? Theorem, which hopefully you also know this as well. All right? If I ask for exact, I want you to leave it as a radical. If I ask for a decimal, put it into your calculator. So if I say round, that means plug it into your calculator. If I say exact, it means leave it as a radical or a square root, okay? It does not matter what A and B are as far as order, as long as they are the legs. So A and B are going to be your legs. Your C is always your hypotenuse, always your hypotenuse. So pay attention as to what they have given you so that you set it up correctly. So x squared plus the square root of 13 squared equals the square root of 14 squared. The other thing that I see a lot is that you stop at the squared. Now this is 1, so it's easy. But make sure you take the square root as your last step, because whatever you have found in Pythagorean theorem is that number squared. All right, so you're not done until you get to the end of this. For this one, you would say 5 squared plus x squared equals 14 squared. All right, so 25, right? I don't think this is going to have a 21. I don't know. 2. Yeah. He does not have a square root. So in this case, if I wanted you to leave it as a root, you would simplify it as much as you can. If I wanted a decimal, you'd plug it in. All right. And this guy's actually divisible by 3. But then that's not divisible. So for this one, if you simplified it using your factor tree, you can take a 3 out. But this wants you to tell me, is this a right triangle, an obtuse triangle, or an acute triangle? All right. So if your c squared equals what it should be, right? So let's say they equal. Then that means you have a right triangle. If your c squared is too big, he's bigger than what he should be, then you have an obtuse, all right? And if your c squared is too small, so he is smaller than what he should be, you have an acute, okay? So your a squared and b squared tell you what your c squared should be. If your c squared is larger than it should be, obtuse. Smaller than it should be, acute. And if it's the same number, that means you have a right triangle, okay? And so you're literally going to say, this is the biggest side. You can see that it would be a hypotenuse. And you're going to set up a squared plus b squared equals c squared. By the way, I get a lot of questions on... This is actually this whole thing squared. All right, I get a lot of questions on how to do this right here, this first part. You square this, that's just 9, and you multiply it by just what's inside, because the square root goes away when you square it. So you're gonna get something like that. 9 times 23 there, which is like 180 plus 27, so what, 207? Okay, so... And then you just do it like this. And then 16 squared is 256. And so then you add those up. These tell you what your c squared should be, all right? So your c squared should be 232, but it is 256. What type of triangle do I have? Yeah, I have an obtuse triangle. My c squared is too big. My c squared is too big. So I have an obtuse. If it had been 212, it would have been acute. If it had been 232, it would have been right. All right? I look at this triangle and it wants the area, and the area is 1/2 base times height, and I do not have a base or a height here, okay? It's not a regular polygon because all of those sides are not the same length. So I must use 1/2 base times height to solve this guy. All right? I do not have the height, but I know this is an isosceles triangle because those 5s are the same, so I can draw that down. That is my height. And on an isosceles triangle, that guy cuts the bottom in half. So this little piece of it's 2.4. So I have this right triangle. The height is what I need. I have a base of 2.4 and a hypotenuse of 5. I can use Pythagorean theorem to solve for my height. So to solve for my height, I would say, oh, that's a squared plus my b squared, which is the height that I want, equals my c squared. And then once you solve for height, you plug it in. 1/2 base they gave me, height I just solved for using Pythagorean theorem. Okay? So that's all this whole entire page is about. It's about isosceles triangles. Or pieces of triangles, and you're using the pieces. All right? Sometimes it's not isosceles. When it's like this is isosceles, sometimes it gives you two different pieces of a triangle. So it'll give you one that's not isosceles, but it will give you this guy, and it'll give you two pieces here, and it'll give you two pieces here, and you're solving for your heights that way. All right? So you're just, this whole page is still using Pythagorean theorem. Still using Pythagorean theorem to solve for part of the triangle you need to solve 1/2 base times height. All right, so special right triangles. How do I know it's a special right triangle? I have that 60 in the corner. That 60 tells me I have a 30, 60, 90. Had it been 45, I would have known I had a 45, 45, 90, okay? And so I know I have a special right triangle. You have to have these memorized. 45, 45, 90, the side lengths are the same. The hypotenuse is the side times square root of 2. 30, 60, 90, short side is what you're all basing everything off of. Your long side is that short side times the square root of 3, and your hypotenuse doubles the short side. In this case, they gave me the hypotenuse. So I know the hypotenuse equals my short side, which is B, times 2. So if I want to solve for B, I'm just going to divide this guy by 2. Remember, when you're dealing with radicals, you can reduce the outsides and you can reduce the insides, but you can't reduce outside to inside. So that guy reduces to 4 square root of 5. So I know my B equals 4 square root of 5. That's my short side. My longer side is going to be my short side times the square root of 3. I know my short side. So if my short side equals my long side equals my short side times the square root of 3, then I'm going to just say to find A, I take my short side, 4 square root of 5, and I multiply it by the square root of 3. When you're multiplying radicals, you can multiply the outsides and you can multiply the insides. 4, there's nothing for it to multiply by, it stays there. I have a 5 and a 3 on the inside. I multiply them, square root of 15. That is my longer side. This is my shorter side. I have solved both of those. So you must know those two special right triangles to be able to do these. So let's look at this guy. Ultimately, what I want to find is this x. So ultimately, I'm trying to find this x, which means I need to start on the other triangle. So on the other triangle, my goal is to solve for that common side. The bottom triangle is a 45, 45, 90. They gave me one of the sides, and I actually need the hypotenuse here. For a 45, 45, 90, my hypotenuse is just the side times the square root of 2. So now I actually know one of the sides of my larger triangle. All right? Specifically, I know the shorter side of my larger triangle. And what I'm trying to find is the hypotenuse of my larger triangle. The hypotenuse of a 30, 60, 90 equals the short side times 2. I double it. In this case, I'm looking for x. It equals the short side of the triangle times 2. I just solved for it, so 8 square root of 2 times 2. Remember, with radicals, you can multiply the outsides and you can multiply the insides. Both 8 and this 2 are outside of a radical. So I'm going to say 16. And the one that's inside the radical, the square root of 2, doesn't have anything to multiply by. So my x is going to equal 16 square root of 2. And I'm done. So when they're combined like that, you're looking for your one that is in common. You're going to use that to solve for the piece they're actually asking for. You will have one where I just hand you everything that you need and I'm really just saying, do you know this formula? Okay? Then you will have other kinds where I am giving part of what you need and you're going to use special right triangles to figure the rest out. Okay, so this first one, you have everything you need. The formula for a regular polygon is 1/2 apothem times perimeter. The apothem is the distance from the center perpendicular to the side. If they give you only one line, the number that they give you goes with that line. So they have given me the apothem. So I already know 1/2 times 5.5. That's my apothem. Technically, they did not give me the perimeter, but they did give me one of my sides. And I know how many sides I have. How many sides do I have?
6.
5?
No, 6.
So I'm going to say 8 times 5.
I was looking at the wrong one.
All right, so 8 times 5 is my perimeter. 1/2 apothem times perimeter. Multiply and solve. Okay? Multiply and solve. So, for that one, it's very simple. The only problem that I ever see people make here is that they accidentally plug in just an 8 for their perimeter instead of 8 times 5. All right? So make sure you actually multiply it out and give me the perimeter, not just the side length there. All right? Perimeter, not just the side length there. Now the next one requires a little bit more work. For this one, they gave me a side. So the perimeter's easy. So if I'm using that formula, I already know my perimeter. Yes, that's 6 sides, and it's 10, so my perimeter here is 60. What I do not have is my apothem. I do not have my apothem. So this is where I am going to create this triangle. Now we just did this with our areas. This is actually an isosceles triangle, all right? So when I create this, I actually cut this side in half, so that's going to be 5, all right? And it's a special right triangle. 6 sides divided by 360 is 60 degrees, and this is always going to be half of that. I have a 30, 60, 90 triangle, and they have given me these. I have figured out the short side is 5. My apothem is the long side of a 30, 60, 90 triangle. So it's just the short side times the square root of 3. 5 square root of 3. That is my apothem. All right? So when I plug this back in, I'm going to say 1/2 apothem times perimeter. And you can do all of that in your calculator. 0.5 times 5 times the square root of 3 times 60. All right, the only thing I would say watch for when you put in the square root of 3 in your calculator is that you get out of the radical before you multiply by 60. Because sometimes in your calculator, it'll keep everything behind it inside the radical. So make sure you arrow out of your radical before you multiply by 60 there. All right. It says round to the nearest tenth. So watch your rounding as well. 1 decimal place. Make sure if you round within the problem, you show me your steps. I would also always write this piece out. If you just take it and plug it into your calculator and do not write it out, I will not give you any partial credit on it. All right? I must see what you did in order to see if you had at least some of the steps correct. All right? All right, so you should know your radius. Your diameter is going to be double your radius. Your circumference is going to be 2 pi r, or diameter times pi. And your area is going to be pi r squared. That's what you need to know about the circles. And then we'll get to sectors. All right? So if it wants area, pi r squared. They gave me diameter. Cut it in half. So this is going to be pi times 2 squared. If they give you the circumference and they want the radius, the circumference is 2 pi r. Divide both sides by that 2 pi. And you can do that in your calculator. 62.8 divided by 2 pi. Make sure you parentheses there. It'll multiply at the end. All right. If they want the diameter, so you're going to have it, you know, as a kind of a chart. The area is pi r squared. You need to divide by that pi. r squared equals whatever this number is. So you are going to have to take the square root, but then you just found r. What did they ask for? Diameter. So when you get this square root, you have to double it because they're asking for diameter. So pay attention to what you're answering in the question. Pay attention to what you are answering in the question. And we'll get into segment too. All right, so sector, that is your angle over 360 times your area. All right, so for this guy, I want my angle, that's 315, divided by 360. And you are going to multiply that by pi r squared. And again, you can do all of this in your calculator. You can say 315 divided by 360 times pi times 6 squared. You can do all of that right in your calculator. You are breaking these up into figures that you know. So we have a triangle, 1/2. Base, the base of the triangle is 9. The height of the triangle is 2. That would be the triangle piece of this. And then you have a rectangle. The rectangle is base times height. That's where you saw for this piece of the area. You add your two areas. So you add your triangle plus your rectangle, and you get your total area. For something like this second one, you have a rectangle. Your rectangle is base times height. So we have base times height. That's my rectangle. Then I have a circle. They gave me the diameter of the circle, by the way. So for the circle, I'm going to say pi. My radius is 3, pi r squared. I add my rectangle and my circle. No, the circle is split. Half of the circle's on the right-hand side, half of the circle's on the left-hand side, because I have a cylindrical type of picture here. But either way, you're adding a rectangle and a circle. So when you do these composite figures, you're literally just breaking them up into ones that you just did for me. You just did all of these. You're breaking them up into ones that you know. All right? So you have several of those, and I gave you the answers for those as well. And then you have a handout for rhombus, and you have a handout for segments. For the rhombus and kite, they give you the formula at the top of the page. It is 1/2 your diameters multiplied together, okay? So when it says AC here, it tells you that it gave you AC, that is one of the diameters. When it tells you that it gave you BD, it gave you the other diameter. The formula is 1/2 diameter 1 times diameter 2. Plug it in. 1/2, 12 times 4. All right? 1/2, 12 times 4. So 24 square inches. So remember, for a segment, you're going to do the formula for your sector, which is your angle over 360 pi r squared. So you take your sector and you subtract your triangle. And what's left over is your segment. All right. So they told us our angle measure here is 68 degrees. So we take 68 degrees over 360 times pi. Q to R, they gave me P to L, and they gave me P to Q. All right, so P to Q is actually my radius. That is my radius. So they gave me the other piece that I need here, pi r squared. That is my sector. And I need to subtract my triangle. 1/2 Base. My base is QR. QR is my base. And they gave that to me right here, QR. So 1/2 base. And then my height is PL, and they also gave me that. Base times height. So when you're trying to find segment, you take the entire sector, what we just did, angle over 360 pi r squared, and you subtract out the triangle piece of it, 1/2 base times height. And then what is left over is your area of your segment,